Hi everyone, we're going to learn a few more things about covalent bonding. So the vocabularies you're going to get today is bonding electron pairs, non-bonding electron pairs, double covalent bond and triple covalent bond, polar covalent bond and non-polar covalent bond. Please, whenever you see those vocabulary in this presentation, please write those down. Okay, first of all, let's look at the double covalent bonds. So between two different kinds of atoms, they can share two pairs of electrons. We call it a double bond. It's, for example, when two oxygen combine together, one oxygen has 6 valence electrons. Each one of them needs 2. So this oxygen will contribute 2 electrons, and this oxygen contribute 2. So these two pairs, we call them two pairs, basically one pair up with the other one. This we call them double bonds because they're sharing two pairs, one pair, two pairs. Okay. So at this time, when they share those, this oxygen would have 1, 2, 3, 4, 5, 6, 7, 8. Those all 8 belong to this oxygen. And this oxygen also have 1, 2, 3, 4, 5, 6, 7, 8. So these two pairs belong to both. It's moving around both, make this oxygen molecule. That's the thing we breathe in every day. Okay, and we call those shared electron pairs bonding electron pairs because they basically form the covalent bond. Okay, and then the ones that are not sharing, like those ones, we call them non-bonding electron pairs. The non-bonding one is like still belong to, so originally it belonged to this oxygen, now it still belong to this oxygen. It does not move around this one. And also those two pairs belong to this oxygen. It just move around this oxygen atom. It does not move around this one. So those are still belong to each other individually. So we call them non-bonding electron pairs. Okay. So one thing you need to know is they can share two pairs. That's we call it double covalent bonds. And the shared pairs, we call them bonding electron pairs. The unshared pairs, we call them non-bonding electron pairs. Okay, with that said, between two atoms, they can even share 3 pairs. In this case, we call them triple bonds or triple bonds. Basically, let's look at this nitrogen. Nitrogen have 5 valence electrons. Each one of them needs 3 more. So what gonna happen is this nitrogen contributes 3, and this nitrogen contributes 3, and those 6 electrons forms 3 pairs. We call them 3 pairs, and those 6 now belong to both. Okay, and now this nitrogen have 1, 2, 3, 4, 5, 6, 7, 8. So it's very stable, and this nitrogen have 1, 2, 3, 4, 5, 6, 7, 8. So this one also have 8. These 3 pairs move around both. We call this triple covalent bonds. So we sometimes use 3 lines to represent those bonds. Okay, again, those 2 are non-bonding electron pairs. Those 3 pairs are bonding electron pairs. Okay, so the next thing for covalent bonds is in the bond, electrons are sharing. Also, it's like a tug of war. It's like this one want this pair, this one also want this pair. So they can be, so when they share, it can be polar or non-polar. Let's have a look. Okay, there are 2 types of covalent bonds. One is called non-polar, the other one called polar. Let's have a look what's the difference. Okay, non-polar means when they share the electrons, the bonding electrons are shared equally. It means it's moving around both of the atoms in an equal amount of opportunity. Like when 2 atoms are the same, like hydrogen are sharing 1 pair, oxygen are sharing 2 pairs. Those are the double bonds. And nitrogen are sharing 3 pairs. But because these 2 nitrogen or these 2 oxygen have exactly the same strengths, when they do a tug war, they have the same strength. So those sharing electrons are moving around both atoms in the same kind of opportunity. So this we call it nonpolar bonds. Okay, the other type is when they share unequally. When one is stronger, when these two atoms are different, when one is stronger, the electrons would prefer to move around the stronger one more. So we call it, they're sharing unequally, we call it polar bonds. So a typical polar bonds would look like this, okay? One side has more electrons, so the sharing electrons are moving more around one of the atom to make it partially negative because the electrons are moving more around this one. So when it partially negative, we use a sign of this, we call it sigma. So we use sigma negative means this is partially negative. It's not a whole charge. It's not like ionic bonds. It totally gave away. This one is like still sharing, but partially like move around the green one more. So this is partially negative. This is partially positive. So sometimes people also use an arrow to point out where the electrons moving more. Okay, so this is a very typical polar molecule, HCl, formed with hydrogen and chloride. So we call this hydrochloric acid. It's a typical acid. Um, so this is a typical polar covalent bond. So chloride is more stronger, so it's pulling the sharing electrons more toward chloride. So this is partially negative, and this is partially positive. Another example is water. Water is a very typical polar molecule. Oxygen is more stronger compared to the to hydrogen, so the sharing electrons are moving more around the oxygen. So this side is partially negative. This side is partially positive. And this makes water so special. That's why water can dissolve lots of ionic compounds. It's all because it has partially negative charge. It can really attract the negative ions, positive ions in the ionic compound like table salt. Okay. So we're supposed to learn a lot more about polar and nonpolar, and because the time restriction right now, just give you the concept. If next quarter, I mean quarter 3, we have more time, we may just to learn more about the typical structure of water and the properties of water. Okay, so now let's look at the formula and naming of covalent compounds. Okay, so for covalent compounds or molecule, a compound is basically a molecule contains multiple atoms. So this kind of tell you the number of elements in the molecule. And the one thing is different from the ionic compounds is this one, we are not going to reduce it based on the ratio. Remember in the ionic compounds, I said if you have both atom have two, like Mg, magnesium have two, oxygen have two, you can just write magnesium oxide as 1:1 ratio, like MgO. But in here, you cannot simplify it. Like if you have a molecule with 3 carbon and 6 hydrogen in there, it's like really connected together as a molecule. Okay. And you cannot just write a CH2. These two are totally different kinds of molecules. Okay, so just remember you're not going to reduce the molecule based on the ratio. And when we name it, again, because we cannot reduce it, and the same type of atom, like two same type of nonmetals combined, they could form multiple ways. Like, for example, carbon and oxygen can form two different kinds of molecule with 1 carbon and 1 oxygen, or 1 carbon, 2 oxygen. In this case, you cannot just call them carbon oxide. We have to really see how many oxygen are in there, right? This is a very typical chemical called carbon monoxide. Mono means 1. This one is carbon dioxide. Di means 2. So in this case, for a covalent molecule, we have to use the one we call the prefix, right? To tell people how many of that atom is in there. Those are the 10 from 1 to 10, how do we call them? Again, since we don't have a lot of time, I'm not going to ask you to remember those or to be able to use those. Just know it, and get familiar with it. We can always Google it online to figure out, right? So, for example, this one's N2O3. It contains 2 nitrogen, 3 oxygen. We just call it dinitrogen and the trioxide. Again, the same rule as ionic compounds. The first one, keep the name the same as the element. The second element, we're going to change the last part to IDE. The difference between this with ionic compounds is this time we have to really tell people how many of the atoms are in there. So we need to use the prefix. So this one is phosphorus. The first one is 1 phosphorus. We don't bother to write like mono. Okay. So phosphorus, and then 3 chloride is trichloride. And when you say the name, you would be able to write the formula. Sulfur is S, trioxide, so 3 oxygen, write the oxygen symbol and write 3. And this carbon tetrabromide means carbon is C and the tetra is number 4. So you're going to write Br, which is bromide, and write a small subscript 4 in there. Okay, again, this is mostly everything for covalent bond. I'm not going to really ask you to be able to write the formula or write the name. Right now, we just get familiar with the concept. Okay, so tomorrow we're going to compare the difference between ionic compound and covalent molecules. Thank you for watching.